Alright, this is 8-1, Intro to Trigonometry. Trigonometry has to do with triangles, and it's sort of one step further in the process of trying to figure out missing side lengths and missing angles inside of triangles. So to talk about trigonometry and the trig functions, which we'll get to in a second, we first need to talk about where they came from, and that is something called the unit circle. The unit circle is just called the unit circle because it has a radius of 1, and it's centered on the origin of like the coordinate plane, so it's centered on 0, 0, and it has a radius of 1. This is something we call the unit circle. And inside of this unit circle, we can draw any kind of right triangle that exists in the world. And so what I want you to do is just draw a triangle, and it has to follow these rules here. It says one corner must be on the origin, so we'll just make one corner there. And then a second corner has to be on the circle itself. So I'm going to make my corner here. And then the last corner must be on the x-axis to form a right angle with the x-axis. So we have to just make a straight line down from that guy, and this will be the third point in our triangle. So we've created a triangle, a right triangle inside of the unit circle. And we're going to say that we measured that angle and it's 65 degrees. On yours, it would be great if you had like a protractor to measure that angle that you drew, but either way it'll be okay. So we have like that central angle there is kind of important for what we'll talk about next, the one that's attached to the corner that's touching the origin. But inside of this unit circle, the angles and the edges of this triangle are related, and that's true about any triangle. But we have specific sort of like shortcut functions that allow us to find the side lengths of this triangle without having to do Pythagorean theorem or any other kind of like complicated math here, I guess is the best way I can put that. So the functions kind of give us a way to immediately find side lengths from an angle because we know they're related, and these functions happen to be how they're related. So I really like this image here because it kind of gives you an idea of what each of these functions do. So first let's talk about what they are. The three trig functions are called sine, spelled S-I-N-E, cosine, and tangent. On calculators and otherwise, these are abbreviated to be 3 letters. So sine is usually S-I-N, which please don't pronounce that sin, it's sine still. And then C-O-S for cosine and T-A-N for tangent. So they're just special functions that give us the side lengths of any triangle we can draw in the unit circle using its reference angle. So that's what we'll call this central angle that we labeled up here. That is going to be called the reference angle. So they just relate the angles inside the triangle with the side lengths. So using that reference angle, you can immediately get this side length. So let's look at this picture. Using this reference angle, you can immediately get this side length by plugging in sine of, in your calculator, sine of the angle, and hitting equals. That will immediately give you how long that side length is. And the same thing is true about cosine for getting, let me back up here, cosine for getting this side. The third side of this triangle here, this one, is always 1 because it's always a radius of the unit circle. So we don't need to find that side length. It's just always 1. Sometimes we have to, actually we'll talk about tangent in a minute, but tangent is also related. It kind of creates this second triangle with another right angle right there, where we can then find, the hypotenuse of a triangle using tangent, because on this hypotenuse it's just always 1. So we'll talk about that when we do actually problems here. But what we're going to try here is we're going to use this reference angle and this triangle that we drew up here to calculate the side lengths, the vertical side length and then the horizontal side length for sine and with sine and cosine on our calculators. So I'm typing into my calculator sine of 65 because that was my reference angle, and that gives me 0.82. I'm going to do the same thing with cosine now. Cosine of 65, that's my reference angle, that equals 0.56. So let's just talk about for a second why these side lengths make sense for my triangle. Remember that the hypotenuse of a right triangle is always the longest, and we know that that's 1. So that means that the other two side lengths need to be less than 1, which is a good thing because we did get 2 side lengths less than 1. And then we got 0.82 for this side and 0.56 for that side, which visually makes sense too because this looks longer. This side length looks longer than the bottom one. So it's always good to double check that your answers make sense. A little note for you at home, if you are getting funky values when you plug in things with sine, it might be because you are in the wrong mode. So you might have to find the mode on your calculator and switch it to, actually, let me just double check here. It needs to be in degrees. So just make sure that your calculator is in degrees and not radians. Those are just two different ways that we measure angles. So just make sure that it says degrees or DEG instead of radians. So that's just something to make sure of because we're going to be, for the most part, measuring our angles in degrees, not radians. Okay, so we're going to turn the page here. So you might ask why this is useful. If it only works for triangles inside of the unit circle, then why is it useful, right? So the answer is it's certainly not just useful for unit circle triangles. Because we know from similarity of triangles that we can just scale the same triangle up and down however much we want. And the side lengths are going to be proportionally related. So we have two triangles here in this image. One of them is within the unit circle, so we have a radius of 1, so the hypotenuse is also 1. But we scaled that same triangle, same angles, right? So it's a similar triangle. We scaled it up by 4. So our scale factor there is 4. So for example, I could, if I'm looking for the two missing side lengths of my big triangle, what I can do, and you can look back at the picture if you need it, this side of the triangle is sine of our reference angle, which is 40. This is cosine of our reference angle, which is 40. So all we need to do is scale those values up by 4 to get the larger triangle's side lengths. Because we know that they're proportional, so we might as well just multiply them by our scale factor. So this side length is going to be sine of 40 times 4, because we're scaling it up, and this one's going to be 4 times cosine of 40. And I will get those values really quickly. It looks like that's 2.67 for that side and 2.98 for this side. It's always good to double check. I never know if my book is correct. So we have 4 times sine of 40 makes 2.57. Okay, so that's different than what I have. 4 times cosine of 40. Yeah, those are slightly different. I was worried that those would be wrong. I felt like I was remembering that those were wrong from last year. Okay, so hopefully instead you got 3.06. for this side, and 2.57 for that side. Okay, that's a little bit better. So the side lengths make sense, they're both less than 4, and also the longer side is longer, which is good. So you see that we can still use these trig functions basically with any right triangle ever, because we can make any kind of right triangle inside of the unit circle, and then we can just scale it up to whatever other size that we need, right? So using that idea, we come up with these 3 trig definitions, and trust me when I tell you, all this is scaling up and down triangles. But these 3 definitions are the things that you absolutely need to learn this unit. Otherwise, you won't be able to do anything. And it's actually not too bad to memorize them. I will give you a little bit of a memorization technique on these in just a second, but just so we see here, something that's super important is being able to recognize which side is opposite, which side is hypotenuse, and which is adjacent. So you always need to know where your reference angle is. So in this picture, my reference angle is in the bottom left-hand corner. The hypotenuse it's always going to be the longest side. It's always going to be the side that's not touching the right angle. So your hypotenuse is usually pretty easy to identify. The other two, the opposite is going to be opposite the reference angle. So again, I sort of think of a flashlight, this is a little bit of a flashlight, and it's shining on this wall right there. So that's my opposite side. And then the adjacent side is the other one that's touching the reference angle. So adjacent is just a fancy word for next to, and so your reference angle is right next to the adjacent side. So the trig definitions are that sine is equal to the opposite side, and these are side lengths, the opposite side length over the hypotenuse. Cosine is the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent side. So the way that most, actually this is just a really common way to remember this, is it's so early in the morning, I can't remember what the word is for this, but you can remember SOHKAHTOA, and they pronounce this SOHCAHTOA. So if you can remember SOHCAHTOA, then you can remember that sine is equal to the opposite over the hypotenuse, cosine is equal to the adjacent over the hypotenuse, and tangent is equal to the opposite over the adjacent. See how that works? SOHCAHTOA. Yeah, so that's how I remember it, and hopefully that will help you remember this as well. So let's turn the page. This first little bit here is just helping us to identify the opposite, adjacent, and hypotenuse sides, because that's exceedingly important to be able to use trig functions. So the reference angle is always indicated like this, where it has this theta symbol there. So our reference angle is, again, super important for where the other two, the 3 named sides are. So for all 3 of these, I can tell where the hypotenuse is because it's the side that's not touching the right angle, and it's the longest side. So there's the hypotenuse for all of them. Now I'm going to do opposite. The opposite side is always opposite the reference angle. Opposite and opposite. So we now have all of the opposites, and then the last one is just adjacent. It's the other one that's touching the reference angle besides the hypotenuse. Yeah, so that's really important to be able to recognize where those 3 things are. And you'll see why in just a second. So here we have a couple of triangles. They're not unit circle triangles, they're scaled up or down a certain amount. And we're going to use the trig definitions that we learned on the previous page to find out what x is in these triangles. So our reference angle is always going to be the one that they gave us, 53. Theoretically, you could use the other angle because you could figure out what this angle is, but we don't need to. We have an angle already. So the most important thing here, the first step, I guess, is to figure out what sides you have. So your reference angle here in the corner, I have on this triangle my hypotenuse. It says it's 4, and then the x is my opposite side. And then you ask yourself, which of the trig functions uses opposite and hypotenuse and not adjacent? So we look back at our trig definitions. The one that uses opposite and hypotenuse is sine. So we're going to set up a little function here. We're going to say sine. It's always sine of your reference angle, so sine of 53 degrees in this case, equals the opposite side, which is x, over the hypotenuse side, which is 4. So this is opposite over hypotenuse. And then you just solve for x. So sine of 53, even though it looks confusing, that is just a number. And so we don't need to do anything with that besides plug it in at the end or at the beginning. It doesn't matter actually when. What I'm actually going to do is I'm going to multiply both sides by 4 here to get the x by itself. And I want you to notice here that what we're doing, just like we talked about, what we're doing with this trig definition is we're scaling this triangle up by 4. Do you see that? Because the hypotenuse of this triangle is 4, so we're scaling up the unit circle triangle by 4. That's not exactly like necessary to know for being able to do these problems, but it is like, I just want you to see that we're not doing anything like really like a huge mystery here, right? We're just scaling up unit circle triangles with these trig definitions. And then the last step is just to plug that into a calculator. 4 times sine of 53. So I will do that on mine really quickly. Sine, actually, we'll start with 4 times sine of 53, which is 3.194. So I'm going to say 3.19. We'll just round to 2 decimal places. 3.19. And that's how long x is. That's the x side of this triangle. So let's do it again. Let's get used to this process here. So the first step is to identify your reference angle, which in this triangle is 40, and then figure out what two sides you're dealing with. For this one, we're dealing with the hypotenuse and the adjacent side. And if we peek back at our trig definitions, adjacent and hypotenuse, you need to use cosine. Adjacent and hypotenuse. So we're going to use cosine. We'll set up this equation that says cosine of 40 equals the adjacent over the hypotenuse. So this is x over 3. And then I'm going to multiply both sides by 3 just to solve for x, because we have our trig function all set up. We just need to solve for x. So we multiply by 3 and we get x equals 3 times cosine of 40. And again, you see that we're scaling up this triangle by 3, like a unit circle triangle by 3. So 3 times cosine of 40 equals 2.30. And again, if you're getting weird numbers in your calculator, double check that your calculator is in degrees mode, because otherwise it's going to give you different answers. So last one, again, identify your reference angle. So this is our reference angle here. The two sides that we're dealing with are opposite and adjacent. So the opposite and adjacent trig function is tangent. I won't turn the page again because sometimes that makes me seasick. Tangent deals with opposite and adjacent. So the tangent trig function says that tangent of our reference angle is equal to the opposite side over the adjacent side. So we get x over 11. And we multiply by 11 on both sides to solve for x. So we get 11 times the tangent of 25 equals x. And then x is, if we plug that in, 11 times tangent of 25, 5.13. And 5.13 is how long that missing side length is. So that is how you use trig functions to find missing side lengths in triangles. I don't have room on this page. Do I have room on this? We do. Okay. I forgot that I added these in here, which is very good. Okay, so a couple more practice problems here. And you will see how these are a tiny bit different. So again, we have our reference angle here of 57, and the two sides that we're dealing with here are the hypotenuse and the adjacent sides. And that's cosine of 57 equals the adjacent over the hypotenuse, so that's 10 over x. So see how this one's a little bit different because our x is actually in the denominator and not in the numerator, so it takes like one more algebra step to solve this function here. That's why I added these, because there's several like this on your homework and basically everywhere. So the first step on these ones is to multiply by x, so the x is no longer in the denominator. So then we have the function x times cosine of 57 equals 10, which is not useful yet, but we can divide by cosine of 57, because even though it's like a trig function here, it's just a number because we can plug that into a calculator and get a number. So that means we can divide both sides by it, and that cancels that, and we get x equals 10 divided by cosine of 57, which then we'll just plug that into a calculator. So 10 divided by cosine of 57 is 18.36. So it's very similar, but we have like two more or maybe one more algebra step than we do on the other kind. That just is because the x ended up in the denominator of this fraction instead of the numerator. So we can practice that a couple more times here. So reference angle 36, we're dealing with the opposite and the hypotenuse side. So that's S-O-H, so katoa. So sine of our reference angle is equal to the opposite over hypotenuse. So again, the x is in the denominator, so I'm going to multiply by x on both sides, and we'll have x times sine of 36 equals 21, and then we're going to divide by all of this stuff. And then we'll get x is equal to 21 over sine of 36, which is, in your calculator, 21 divided by sine of 36, 35.73. Last one, we have a reference angle of 43, and we're dealing with the opposite and the adjacent sides. So we have tangent, wrong color, tangent of 43 equals 6 over x. So something that people notice here when we do this algebra, what we're doing is we're switching from let me use this. When we're switching from this original statement to this, what happened here is we switched the x and the y. We took a couple of algebra steps to do that, but we just switched the x and the sine of 36. So some people like to sort of skip through this algebra because they know what's going to happen, which I'm okay with. If you can tell that these two things are just going to switch places when we do our algebra, then that's all right. I just need you to know why that happens and not just that it happens. Anyhow, so I want you to be able to do this algebra, but I am okay if you skip that step because I know it ends up the same every time. So anyhow, so once you have 6 over tangent of 43, then you can plug that in, tangent of 43, and I get x equals 6.43 as my missing side length. So that's our trig, our intro to trig lesson. So if you have any questions, let me know. You have homework on this on Math Space. And yeah, let me